Okay. So again, we're doing 5.2 today. And I want you to get your trig identity sheets out. So I've told you that I'll have like prettier sheets for you, but I really want you to build these yourself. So this is what we built the other day. I think this is all we have on our sheet right now. Does this look good to you guys? So you have your reciprocal identities. So sine is the same thing as 1 over cosine. We have our special ones where I've got sine squared plus cosine squared equals 1, and then 1 plus cotangent squared equals cosecant squared, and then tan squared plus 1 equals secant squared. And then we were able to kind of break all of that down from here. All right, from here, we're going to take our notes as well. Let me get those up, and we're going to just go through 5.2 as much as we can. I have another day allotted to 5.2, but I'd like to get as much of the notes done today as possible. And then if I can do more practice with you tomorrow, that would be awesome. Okay, so if you look, I've got 4, 5, 6, I only have 6 problems in here, but these look a little bit more complicated. Do you know anything different between these and like the ones you just did for homework? What do you see that's different? Lauren? It tells us to verify, so the directions are a little bit different. Donna, were you gonna say something? They kind of have the answer there, so you know where you're gonna go. So I want you to pick one side or the other, and then we're gonna simplify it to that side. I like to always pick the more complicated side. So if I'm looking at this first one, I'm gonna pick the left side because that's the more complicated one. And I know that I'm done when I get the answer that's on the right side. And I'm literally gonna do that. I'm gonna do all my work, and then I'm gonna draw an arrow, and I literally draw a smiley face, be like, yes, I made it, I did it, I got there. That's my like personal reward for doing that. So we're gonna take the complicated side, sine squared plus cosine squared, all over cosecant squared. Okay, using your trig identity sheet, do you see anything we can do immediately? Lauren?
Sine squared plus cosine squared equals 1.
Awesome, and I saw a bunch of hands that kind of reached up for that. Sine squared plus cosine squared equals 1. I love that we're recognizing that. So that whole numerator just becomes 1. So now I've got 1 over cosecant x. Does that look like something that we've seen? What's that the same thing as? Sine x, right? That's our very first reciprocal identity. 1 over cosecant is the same thing as sine x. So I see that that's equal to sine x. I draw my little arrow and I draw a smiley face and be like, yes, I did it. And we're good. Wasn't too bad, was it? All right, let's do another one. Okay, tan over secant equals sine. Which side should you start with? The left or the right? Left, good. Start with the more complicated side. Okay. All right, tan over secant. What do you propose we do to start this? Yeah, Hunter, sorry. Perfect. Tangent becomes sine over cosine. What does secant become? One over cosine. So I like that Hunter got us on the path of putting it down into terms of sine and cosine. So if we don't have an immediate replacement, like we had sine squared plus cosine squared equals 1, then I want it to get broken down into sine and cosine. What can I do with this big ugly fraction? Multiply by the reciprocal. Awesome. You guys are doing so good this morning. I'm really impressed. So the reciprocal of 1 over cosine is cosine over 1. And what does that become? Cancels out, and I just get sine x. Is that what I wanted? Heck yeah, smiley face. You did it. Good job, you guys are doing so good. Okay. All right, so now you're probably like, yeah, we did really good on the easy ones, and now you look at the next one, you're like, oh, I don't know if we can do this one. But I know you can do this one, okay? Which side is the more complicated side? Left. So we're gonna start on the left side, okay? I've got cosine times tangent plus sine times cotangent. Okay, you can do one of two things. You can immediately distribute that cosine through everything and then you can simplify, or we can simplify and then distribute that cosine through. It doesn't really matter to me. And actually for today, let's just multiply that cosine through everything and then we'll break things down and simplify from there. Because I think this is going to be pretty simple. Cosine times tangent is just going to be cosine x tan x. And then cosine times sine times cotangent is just literally going to be all of those trig functions in a little row. Cosine x, sine x, cotangent x. If it makes you happy, you can put little multiplication signs in between them. Those are multiplication, not minus. So if you get confused, that's just what they mean, multiplication. Now, if I go to simplify, what should I do? We kind of just unfactored, so we don't want to do that. What did we do a minute ago when we had tan and secant? Hunter? Good, break down tangent. Anytime I kind of get to a place and I'm like, oh, I'm a little stuck, I put things in terms of sine and cosine, and that's what Hunter means by breakdown tangent. So I like to think of cosine of x as cosine over 1. We know tangent is the same thing as sine over cosine. We just did that one. On the next part, cosine is still cosine over 1, sine is just sine over 1, but cotangent is, oh, it's right on my board, cosine over sine. I can do these two things simplified together, and I can do these three things simplified together. Why can't I like cross-contaminate? Why can I only do the greens together and the yellows together? Yes, Sydney? They're multiplied, good. And are the green and the yellow multiplied together? Nope, they're being added together, so they're separated by that plus, so you cannot get any cross-contaminating there. But it actually works out because in the green, does anything cancel? Cosines. So I'm left with just sine. And does anything cancel in the yellow? The sines. And what am I left with? Cosine squared. OMG, and what does that mean? We got the answer, we're done. We did it. You guys are rocking this. How do you feel? Feeling okay? All right, let's keep moving. All right, let's go to number 4 now. It says tangent plus secant equals cosine over 1 plus sine. Which side looks messier? Let's go to the right side. Let's do that one first. I don't have my key in front of me, so this might be interesting, but I think I want to start with the right side first, okay? If I have this right side, well, remember on the homework how you multiplied by 1 plus sign on something? Do you remember why you did that?
I think to get I think it was to get it on top,
Mm-hmm.
so I could like cross multiplying by.
Yeah, that's a good thought. What I think here is that I want to get this 1 minus sine simplified down. We know tangent is the same thing as sine over cosine, right? So essentially this is sine over cosine. I'm writing it really tiny because I'm not really using it. I'm just kind of thinking in my head. And secant is the same thing as what? 1 over cosine. So essentially, if I can get some cosines in the denominator, I can go somewhere from this, right? Okay, I'm going to multiply by 1 plus sine on the bottom because that's going to help me get here. If I multiply 1 minus sine times 1 plus sine, and whatever I do on bottom, I have to do on top. That's going to get me cosine squared on the bottom, and that might be helpful as we move along, okay? So let's do that. On top, and I don't want to distribute on top until I know that I have to, okay? Let's not distribute on top. Let's keep that as cosine times 1 plus sine. But let's do the bottom, which again, you still might not be convinced on what I'm doing and why I'm doing it. 1 times 1 is 1. 1 times sine is gonna be sine. Negative sine times 1 is minus sine. And then negative sine times positive sine is negative sine squared x. Now you might have skipped this middle step because what am I about to do? Cancel those signs in the middle. So those are going to cross out. So I could go, you could have skipped that step that I just did and go directly to cosine of x times 1 plus sine all over 1 minus sine squared. Now I told you we were kind of leading our way here, right? What is 1 plus sine squared the same thing as? Cosine squared. Good. So I can replace that whole denominator with cosine squared. And again, I kind of told you we had to go here. That being said, now that we're here, why do you think it's helpful that I got cosine squared on the bottom? Sydney? Good, I've got a cosine on both top and bottom, right? Those can do what? Cancel. We're gonna cancel those out. These are gonna cancel. The cosine on top completely goes away, but I'm still left with 1 cosine in the bottom. So now I've got 1 over sine, or sorry, 1 plus sine all over cosine. I'm running out of space. I'm gonna have to come over here. So I cross out my cosines. I've got 1 plus sine over cosine. On our homework, there was one problem that we had 2 fractions and we brought them together. Right now, I've got 1 fraction. I'm going to split them apart. Do you know how I can split this fraction apart? What's one of my fractions going to be? 1 over cosine. What's my other fraction going to be? Sine over cosine. So since they have a plus sign on top, you can split them, but you need the denominator to go with both pieces, okay? So I'm gonna make this 1 over cos plus sine over cos. Let me get my arrow over here. Ooh, I'm almost there. Can you see what I need to do next? What's 1 over cosine the same thing as? Secant. What's sine over cos the same thing as? Tangent. Have I matched the left side yet? Almost, right? But I need to do one quick thing before I actually match it. So it started with tan plus secant, and I got secant plus tan. What should I do? Just flip it. I'm just allowed to flip it, but I do want you to take that extra step to make it exactly match what we have. So I'm really zoomed away, but we made it, we did it, we matched. So just kind of to recap what we did, we had to get the denominator to be cosine squared so I could cancel out that cosine, and then I split my fraction in half. What I think is hard for you guys to see is how do I get the bottom to be cosine, but now that we've done it, hopefully we can kind of recognize it for the future, okay? All right, how are we feeling? We doing okay? All right. All we've got is 2 more. All right, let's jump over to number 5. Okay, which side looks more confusing? The left one? Yeah, let's do the left one. We're going to start on the left-hand side. Okay. Now I look at what's given to me, tan squared over secant x plus 1. Does any of that match anything on our identity sheet? Yeah, Gwenna.
Tan squared.
Amazing. That's exactly what I want to use. So I want to take that tangent away and I want to make it secant squared minus 1. You might think, Miss White, why are we making it more complicated? Gwen is exactly right because we see a secant now on top and on bottom. So I've got secant squared x minus 1 on top, and I've just got a secant plus 1 on the bottom. Can we factor or simplify this secant squared minus 1? Can we like separate that? What if I thought of this as, instead of secant squared x minus 1, what if it was just x squared minus 1? How would you factor down x squared minus 1? X plus 1, x minus 1. Do you remember what that's called? Anybody? Difference of squares? But it was like, not what you were gonna say. So that's technically a difference of squares, which we've done before, right? We could do x squared minus 36. We could do x squared minus 250 or 225. Like there's a lot of those different ones. But I can think of this as instead of secant squared, I can think of it as x squared. So now my numerator is going to be, instead of x minus 1 and x plus 1, what's going to be in those parentheses? Secant minus 1 and secant plus 1, right? I'm gonna plan that spacing today. So now the numerator splits up to be secant minus 1 and secant plus 1, and now I've got a secant plus 1 in the denominator. Kind of have my right side in mind, just so I can kind of see what's going on. What do you guys see we can do now? We're gonna cancel it out. We're gonna take those secant x plus 1 and cancel those out. And so now that means I'm left with just secant x minus 1. This is the hard part, because you're like, wow, I feel like we're simple, I feel like we're done, but we don't match the right side yet. So we have a little bit more to go in order to match the right side, but we're exactly where we need to be. What is secant the same thing as? 1 over cosine. Do I have cosine to my right side? Ooh, I'm itching towards the right side. Okay, so secant is the same thing as 1 over cosine. So I can think of this as 1 over cosine minus 1. How do I end up getting those two things as one fraction? How can I end up combining these two things into one fraction? Yeah, Diamond. Like the range that. Yep. It's not, it can't just be secant minus 1, it's not gonna be like the x. Technically, you can write secant minus 1. The x is just the angle of it. Sometimes I get lazy and my x's fall away, and so I'm trying to remember to bring them back. It's not technically wrong, but it's most right to have the x go with you. Because you just wouldn't have secant by itself, it's secant of an angle. Does anyone know what I need to do to get these two into one fraction? What if I had like 1/2 minus 1? What would you do to get those two to go together? Go ahead and make it like denominators, right? Multiply that by times 2 over 2 so that I can have a like denominator. What should I multiply this 1 by? What over what? So it has like denominators of cosine. Cosine, right? Multiply by cosine top and bottom. We want like denominator. So I already have cosine as one of my denominators. I'm going to multiply that 1 by cosine on top and bottom. So technically that becomes 1 over cosine minus 1 turns into 1 minus cosine over cosine. And now can you combine that into one fraction? It's all over cosine, right? And the top is just going to be 1 minus cos. Is that what we wanted? Nice. How are we feeling? Okay. All right, I got one more to do with you all together. Oh yeah. What if this looks like
prove that it equals that?
So the word verify is another way to say prove. So basically, I'm telling you that this is a true statement and we are showing the work to prove why it's true. These are basically trig proofs. So if I labeled it as a trig proof and like set up as a 2-column like I did back in geometry, I bet we would all flip, right? But because we're doing it, simplifying it out, this feels a little bit different, but basically you guys have just done 5 trigonomic proofs. It's a pretty good way to start a Tuesday, right? We got one more, okay? One more. All right, which side looks the most confusing, the most complex? The left. We're gonna do the left side, okay? What do we want? What do we want first? Let's get some common denominators because we want that to all be one big fraction, right? I think the easiest way is to multiply by what you see the opposite denominator. So I'm gonna multiply the first fraction by sine. You can make it sine x if you don't like sine t, it doesn't really matter, it's just a variable. Multiply by sine t on top and bottom, and I'm gonna multiply by 1 minus cosine t on top and bottom of my second fraction. Okay, when I do this, I'm gonna distribute on top, but I'm not gonna distribute on bottom until I know that I have to. Okay, I want my numerators to be like in like terms, multiplied out. I do not want my denominators to be yet. So my first fraction is gonna be sine squared t. And actually, what's stopping me from not just combining them right now? Can I just combine these two into one fraction right now? Yeah, let's just do that. Why make it 2 steps if it can just be 1? All right, the denominator is gonna be sine t times 1 minus cosine t. If you do distribute that sine t, it won't be a problem, but I'm hoping to cancel something eventually because over here we just have sine in the bottom. So I don't want to multiply by that 1 minus cosine if I don't have to. Now I'm gonna distribute this over here. I'm gonna do 1 times 1 is 1. 1 times negative cosine is minus cosine. Cosine times 1 is positive cosine. And then cosine times negative cosine is negative cosine squared. All right, we can cross out those cosines, right? So now I've got sine squared t plus 1 minus cosine squared t. All over sine t 1 minus cosine t. Give me a second, let me see where I want to go with this. Does anyone have an immediate thought? Lauren, what are you thinking?
First person is the 1 minus cosine.
We can't do that because I got a plus right here. Can't do that. Let's do this. What's 1 minus cosine squared the same thing as? Sine squared. Would that be helpful, you think, if we got rid of that and made it a sine squared? Because what else do we have in the numerator? Another sine squared. Could we add sine squared plus sine squared together? Yeah, that gives me somewhere to go. I feel really lost right here. So let's actually do that. Let's replace that 1 plus or 1 minus cosine squared. Let's make that sine squared. And that's still all over sine t 1 minus cosine t. What is sine squared t plus sine squared t? Not 10 to the fourth, that'd be if we multiply them. 2 sine squared t. This is another one of those, like, we've done much harder stuff, so then we add 1 plus 1 and we have a hard time getting 2. All right, this next step might feel a little counterintuitive, but what do you see? What can we do? When you think we can? Is there anything we can cross out, anything we can replace? I see something we can cross out. I have a sine top and bottom, so I'm gonna take that sine squared and that sine and cancel those out. So I've now got 2 sine t over 1 minus cosine t.
Wait, I think you cross that out from the bottom. There's no square.
Good, because it's like if I had like an x squared over x, and so there's an x in each of them, so I can take that x out. Or it's like if I had like 4 over 6. I guess 4 over 2 would be a better example. They don't go all the way through with each other, but I can take 1, 2 out, and I'm left with a 2 on top, but I'm left with nothing on bottom. All right, the reason I said that feels probably counterintuitive is because the answer has a sign in the bottom. So you're probably like, Ms. White, why are we getting rid of that? Because we want that sign there. Well, we don't want that 1 minus cosine there, and so we're gonna have to deal with that, okay? So I've got this 1 minus cosine squared, and it looks like on the top that 1 plus cosine. Sorry, I don't know why I keep saying squared, it's just 1 minus cosine, just normal 1 minus cosine. It looks like in my final answer, I've got 1 plus cosine on top. What do you think we should do in order to get that kind of into the play? To where? Top and bottom, good. Donna says, let's just throw it in there. If you do something on top and bottom, it's still an equivalent fraction. So let's multiply by 1 plus cosine t on top and bottom. And again, if you notice in our final answer, we don't want to distribute that 1 plus cosine through, because my answer up here has it by itself. So we don't want to move it through. We're going to keep it as is, but we are going to distribute on the bottom because we don't want that 1 minus or 1 plus cosine on the bottom. So I've got 2 sine t, 1 plus cosine t all over, and let's FOIL this out. 1 times 1 is 1. 1 times cosine is plus cosine. Oh, but I've done this enough times that I know that I'm about to get a minus cosine, so I'm just not going to write anything. And then that becomes negative cosine squared. I'm about to, yep. Why am I allowed to do that? It's one of my identities. Quinn goes, I know that we don't want this 1 minus cosine squared, but we do want a sine involved. So he's gonna go replace that 1 minus cosine squared with sine squared. Ooh, we're so close, I can taste it, guys. Ooh, sorry. So that whole denominator just becomes sine squared. Why is that helpful to us? What am I allowed to do on this next step? Cancel out, good. That sign on top goes away, and I've got just now 1 sign on the bottom instead of sine squared. 2 times 1 plus cosine of t all over sine of t. Did we make it to where we wanted to? We did, yay. All right, you guys did awesome, and what I wanna do, we got a little bit more than 15 minutes in class, I want you to work on your 5-2 homework, okay? In class on Thursday, I wanna review a little bit of this and then probably start 5.3. I do wanna do a quiz on Friday on 5-1 and 5-2. You will get to use your identity sheet on Friday. Okay? There'll be no calculator just because none of this is calculator stuff, but there'll be a small quiz on Friday on 5-1 and 5-2. Yes, identity. And we'll review this tomorrow. Maybe we'll start 5-3, maybe we won't. Yeah, Diamond.
Can I see